All right, so we're going to talk about this virtual MCP server idea. The challenge here is, we're doing something like we have a developer workflow we want to support. It has multiple tools. How do we make that, a better experience of the developer and easier to manage? So here's a potential example. Like we need to look at Jira tickets for requirements. We want to read GitHub issues and PRs. Look at different documentation that we have available internally, query our knowledge base. And so here's sort of the typical example of what that might look like. Obviously, we have to manage multiple connections and configurations. And we can only select things at the granularity of servers, not of tools, right? So if we go back here, like the Jira server has 25 tools, the GitHub server has 51. What if we only need 2 of each, right? We're going to expose all those tools to the LLM, which makes it difficult for it to make choices. And then we have this scattered knowledge. Say if you're using a fetch server, does a developer have to know the exact URLs to go to for the different documentation and so forth? So the virtual MCP server is our way to try to address some of these issues. So it looks like in the diagram, basically you have a single virtual MCP server that the developer would have to configure, and it would manage the upstream servers and how you interact with them. Aggregating multiple tool servers into one interface. We can simplify the tool usage for the developer by pre-configuring various parameters like URLs, API keys, and so forth. That configuration can be centralized in one place, and then we can improve discovery by having only one catalog and only the tools that are actually required. On my little thing here, if MCP is USB for AI, then this is a USB hub. So here's an example request flow. This is very simple. The developer says, I want to see the Python async await docs, calls the tool on the virtual MCP server. The virtual MCP server is also a client, MCP client for the upstream tool. So it is in turn going to call the upstream tool to get the Python docs, say in this case fetch, that gets returned back through and presented to the user. So in this case, the user doesn't have to remember those URLs, you get the automatic routing to the right tool and a simplified interface, which again will benefit the LLM in making the tool calls and the choices. So here's a quick example. We might have multiple tools. These are all, say, going through the fetch MCP server, but they're all going to different documentation sources. This is what it will look like. Under the hood, we're transforming those parameters through the configuration that's defined and calling the upstream server to actually do that. So we wind up with one upstream fetch server, but 5 specifically purpose-built tools to address these different issues. The developer doesn't have to know those specific URLs anymore. The tool will just, through the descriptions or the LLM through the descriptions of the tools, will be able to pick which one is useful. And then we can have like a consistent naming scheme as well, which again will help the LLM. And we wanted this to be just configuration. We have a project going where we want subject matter experts to be providing documentation and other tooling to developers. But we don't want everybody to be writing their own MCP server. We're going to wind up with a whole mess, and they don't want to manage their own servers either. So this is just YAML. Unfortunately, this doesn't fit on the screen, but that's okay. We get the idea here, which is we have an upstream fetch server. There's the URL. And then we're going to configure what are virtual methods. And the virtual method is going to define what parameters are exposed on the user end, but then transform that to what the method call is upstream. So unfortunately, it didn't fit on the screen here, but basically the idea is farther down here. What you're going to see is that there's a method call that says, call the fetch tool, and then here's how you map the parameters from the virtual MCP into the parameters that we pass up to the fetch tool. Again, this is off the screen, but this is the same idea. Like we could actually do some templating where we introduce our own parameter, in this case, like the versions. We could have multiple versions of documentation that are being served by a single virtual MCP server. by doing template substitution of the version number into the URL. So again, we got the static value that you can put in. So this was saying, here's a parameter, but I'm not going to actually expose it for the LLM to fill in. I'm just going to put the value in. So it's always that same value, for example, that URL of the documentation. We can do the template for like things like version, and we also have default values. So some things we're looking at here, one is like secure API access, where we don't want to be injecting API keys into the LLM context or leaving them around in plain text. So we can do this parameter substitution with environment variables. We can have multi-source knowledge. I can have one virtual MCP that sort of encodes all of the knowledge sources for a particular use case or developer persona. And we can also simplify tools. If we have an API that say has 20 parameters, but only 2 of them are really relevant for a particular use case, and the rest have some sensible defaults we can pre-fill, then we can make that a lot easier for the user and for the LLM. We are using ToolHive to support this. There's a number of benefits that we get from that. One is that we get that server management to start and stop the MCP servers. Service discovery, we can find what's available already for upstream servers. We get the isolation, obviously, by running in dependency groups. We get some nice clean cleanup capabilities, metadata tracking of what was already running versus what we started in reaction to the starting the virtual MCP server. And we're also using this new tool that StackLock is working on called the MCP Optimizer, which will allow you to index and search over those custom tool descriptions. Here's a quick flow of how it runs. Basically, the developer will start the virtual MCP server with their config. That gets parsed. We identify the required upstream servers. We check which ones are running with ToolHive. So say we need GitHub, Jira, and Fetch. We find that GitHub is already running, Jira and Fetch are missing. So we start the missing servers. Then we use ToolHive to get the URLs of those servers, build the URL overrides, and then start the virtual server so it points to the correct URL for each server, upstream server. And finally, when we clean up, again, we fetch the server metadata, identify which ones were auto-started, stop those, and stop only the auto-started dependencies. So if the user already had some upstream servers running, that we're not removing them from their configurations. So some key benefits here. Obviously, we have the one connection instead of many, more discoverable tools, particularly directed for a specific use case. Users don't have to, again, know all those different URLs to look up, and we can have a much simpler interface. It's both for people and for LLMs. We also can have centralized configurations. So again, we have teams managing these configurations for us. So there's just one place where, for a particular use case, the developers can go get that config and just use it. Easy to extend because it's just config. Don't have to write code, don't have to deploy a new server. And we also have the templating, which makes it version aware for different environments or platform versions. And then finally, for operations, using Docker and ToolHive makes things a lot easier for us. We get the automatic cleanup. Observability is nice because we get all the different requests going through that one point, and we know, how developers are using those specific tools. And then we get a nice testability through the reproducible environments from ToolHive. Thank you.